Vulnerabilities exist in every computer system. As a system gets bigger, the number of vulnerabilities magnifies. The web is the biggest, most complex computer system that we have, but fortunately, the steps that we can take to secure our web applications are often quite simple. Jared Smith is a cybersecurity research scientist with Oak Ridge National Laboratory. He also has a fixation with JavaScript. He joined me on the show to discuss web application security. But I really wanted to know his position on some of the more grandiose topics that we've discussed on Software Engineering Daily. Stuxnet, the power grid, Russian hacking, corporate backdoors, Mirai botnet. This is a wide-ranging discussion, and I really enjoyed it. But if you want a presentation that Jared gave that's a little more focused on web security, you should check out his YouTube talk at Nodevember. I've linked to it in the show notes. I really enjoyed talking to Jared, and I think you're going to enjoy this too. Incapsula is a cloud service that protects applications from attackers and improves performance. Incapsula sits between customer requests and your servers, and it filters traffic, preventing it from ever reaching your servers. Botnets and denial of service attacks are recognized by Incapsula and blocked. This protects your API servers and your microservices from responding to unwanted requests. To try Incapsula, go to incapsula.com/sedaily and get a month free for Software Engineering Daily listeners. Incapsula's API gives you control over the security and performance of your application, whether you have a complex microservices architecture or a WordPress site. Incapsula has a global network of 30 data centers that optimize routing and cache your content. The same network of data centers that are filtering your content for attackers are operating as a CDN and speeding up your application. To try Incapsula today, go to incapsula.com/sedaily and check it out. Thanks to Incapsula for being a new sponsor of Software Engineering Daily. Jared Smith is a cybersecurity research scientist at Oak Ridge National Laboratory. Jared, welcome to Software Engineering Daily.
Thank you, Jeff, for having me.
So today we're going to talk about web security. And of course, almost everybody who is developing any kind of software today is connected to the web somehow. So when we're talking about web security, what does that even mean? Is that the same as just talking about security?
Well, I think it's more of a subset of security in general. When we're talking about security, we can mean things like computer security, which is any device, or network security, or the hotness now is IoT security. But web security is more of you've got a Node.js web app or a Python app or something, and you want to protect your users against things like sanitizing input incorrectly, or SQL injection, or the more general command injection, anything like that. So I think web security, how I think about it, is any sort of web application that you're presenting to users. I mean, like Google.com, they have security people that would do web security. So that's essentially what it is. But there's obviously other domains of security.
You have said that there is a right way to think about web security. What do you mean by that?
Yeah, so I think it boils down to the mindset that you have going into protecting your systems. I mean, attackers are going to try and come at you from literally any way they can possibly think of. But how I like to describe it, and pretty much the accepted notion within the security community, when you're building applications, you want to build them secure by default. So that being said, that means from the beginning, you're thinking about security. And unfortunately, a lot of people don't do that. And that's why we end up with things like the Yahoo breach or the LinkedIn breach or any of those other companies that have their passwords hacked or stuff like that.
Okay, so this security by design, I am definitely one of those people who builds things without a care in the world for security, because I figure, well, if I end up having security problems, that indicates that I have users, which is like the first barrier to entry to even caring about something like security. So why would somebody do security by design if keeping your system safe requires you to even have people that are using the system? I mean, shouldn't we just prioritize building something that works first?
I think it depends very much on what you're doing. If you're Jeff and you're going to go build your like advertise first, and you don't have any users right now, get it off the ground, get it on the App Store. But that being said, if you're going to accept credit cards from day one, you absolutely need to be thinking about security, whether you have one user or a million. And if that's just saying, okay, I'm going to interact with our API correctly and hash all my passwords with salts and not use something like MD5, then that's good. But if you're Google and you're starting from scratch in a new project, they're probably thinking about it from day one, just because they know as soon as they launch it, they're going to have a lot of users. So it depends very much on what you're thinking. And I, as a security researcher myself and a software engineer, I can tell you a lot of the projects I work on, I don't think about from the beginning. But that being said, it's always there. It's always in my mind. If it's something that I think is going to have a lot of users or is handling sensitive data, I'm going to be thinking about it.
Absolutely. And I think there is not necessarily a trade-off to thinking about security. Oftentimes, you can have implementation A and implementation B, and it's not like implementation A would take longer. It would be more secure, though. You have alternatives, but they're not necessarily more time-consuming, right?
It does very much depend on what you're building. Again, I mean, if you're setting up a network and you're like a sysadmin for some company, it very much makes sense to configure all of your logging correctly, make sure you're having a centralized logging store, make sure you have firewalls in place, and it goes way beyond that. Make sure that your users are educated about passwords, and hey, it's 2017, let's do two-factor auth, because that'll prevent basically all of those other problems with people getting access to people's accounts. So it's a very wide spectrum, and that's why it's so hard, I think, because people often think they know that they're doing everything, but there's always something you're going to forget.
You are unique in that you have both an affinity for security and JavaScript, which puts you at a particularly unique intersection of the software engineering community. What is it like at that intersection? What are the attack surfaces that you are thinking about the most as somebody who is deeply involved in JavaScript and security?
So I think I have a kind of funny story when it comes to JavaScript. I saw web security as like, this is a great topic that not a lot of people are that familiar with outside of the security spectrum. And JavaScript is obviously this thing that's everywhere. We run it on our refrigerators now. So that being said, when you think about JavaScript, the fact that it runs both on the client side and server, I think it makes sense to go back down to the basics and things like sanitizing your input and preventing XSS, cross-site scripting. That goes a long way rather than just trying to cover every other base. If you just cover your most fundamental things like sanitizing input, using correct session management. If you go back in the past and look at some of the vulnerabilities that companies have faced, sometimes they're as absurd as them including session tokens in the URL. And so if someone gets your URL, they just have to cut that session token out and they immediately have access to all of your credit card info for that site. So I think it's really about thinking about the basics and things like sanitizing input, managing your sessions correctly, and hey, hashing passwords with a modern hashing algorithm. I mean, the 2012 LinkedIn breach, the reason that happened is because the passwords were incorrectly hashed, and it would have just been a few more lines of code to do it the right way. So it's sometimes absurd, but I think the basics are what we should fall back on.
If there is a front-end engineer listening to this right now, or I guess back-end engineer also, because Node is obviously back-end, what are the things that a full-stack JavaScript engineer should be thinking about the most about security? Like, what are there some specific things they should keep in mind that are particularly relevant to the JavaScript world?
So there are a few things, but and I have a good in the talk I gave at Nodevember this past November. I mentioned a few libraries. So there's a few things that are particular JavaScript that you should look at. One of those things is there's a library called Helmet.js, and it's done by a really cool guy in the JavaScript community. And that essentially just adds a bunch of headers to your applications that add security protections and keep your cookies safe and other things like that, and prevents XSS to some extent. So there's libraries like that, and you can go and check out that talk or this post I just did on Medium about that. But that being said, I think that when you're developing apps in JavaScript on the back end, it's not much different than doing it in Python or Java or Elixir or whatever it may be. So again, there's libraries to do all of that stuff. I think it just comes down to actually knowing to be thinking about those kinds of things. And I found that it's actually kind of crazy going and talking at these conferences that there's a lot of people that work for places like Facebook and Google, places you think would like know what they're doing, that come to a talk and they have no idea like what I'm talking about. Like I thought this stuff was, taught like the first day of, that class you took in college on security, or just someone mentioned along the line somewhere in a boot camp that you should be thinking about the right way to build your applications.
Yes, indeed. The attack surfaces are growing in number, and the educational ranks are getting less standardized. And so I want to shift the conversation to talking more broadly about security, because you work as a security researcher at Oak Ridge, which is a national laboratory. I have not interviewed many people who work at this type of place. I have a brother who worked at the National Institute of Health, so I have some perspective on the dynamics of a research institution with some ties and like some reliance on the government. But paint me a picture for how a cybersecurity research institution, like how does that contrast with the research that's done at a corporation or a university?
I think the research done at a university is pretty similar to what we do in some sense. And we do a lot of collaboration with both the private sector and the academic world. But specifically, I always like to describe working at the national laboratory where I work. If you have an idea and you can convince someone to pay you for it, or convince someone that it's worthwhile, then you can go do it. You can go lead a team and build it, or do it by yourself. It's a very different world than the business world, where projects are often motivated by a business goal. And I think that's getting a lot better. And it has been in certain places in the industry great, like Bell Labs back in the day. We've got people that used to work there at our laboratory. We have people that built some of the fundamental protocols in the internet that work with us. And so Bell Labs and Microsoft Research and Facebook Labs and Google Research and all those people, they get to do a lot of research that's not as much tied to business goals. But at the same time, I think it's great working where I do, because we have all these agencies and companies coming to us saying, hey, we've got this security problem. Give us your best shot at fixing it for us. And so that's basically what we do. And I mean, we're still not going to be, there's things we're doing that aren't the most advanced, but there's things we're doing that are way more advanced than a lot of other people do. And then these days, the government gets a lot of crap for, all kinds of things. So I like to point out that there's still a lot of great research going on in somewhat government-tied institutions.
Dice helps you easily manage your tech career by offering a wide range of job opportunities and tools to help you advance your career. Visit Dice and support Software Engineering Daily at dice.com/SEDaily and check out the new Dice Careers mobile app. This user-friendly app gives you access to new opportunities in new ways. Not only can you browse thousands of tech jobs, but you can now discover what your skills are worth with the Dice Careers Market Value Calculator. If you're wondering what's next, Dice's brand new career pathing tool helps you understand which roles you can transition to based on your job title, location, and skill set. Dice even identifies gaps in your experience and suggests the skills that you'll need to make a switch. Don't just look for a job. Manage your tech career with Dice. Visit the App Store and download the Dice Careers app on Android or iOS. To learn more and support Software Engineering Daily, go to dice.com/SEDaily. Thanks to Dice for being a new sponsor of Software Engineering Daily. We really appreciate it. What are some of those things that are intensive research efforts that might not proceed at a corporation or university?
In some sense, it depends on what person is coming to us asking for help, or what person we're going after. But we have internal funding proposals where we can essentially propose ideas to the lab itself, and this doesn't come from a business goal of some sponsor or some agency. And then that's pretty much open-ended research. So we have a project right now that's doing some stuff around deep learning and computer security, and these two fields aren't very the security has often been with anomaly detection, those kind of things, just basic statistics. Hey, can we find this event that's out of the normal? But there's not been a lot of deep learning going on. And you can look around at the security vendor space and see that everyone claims they're doing deep learning, but I don't quite think it's there yet. So we're trying to explore some things like that. We have a vehicle security laboratory. We do a lot of malware research. We do a lot of static analysis. So if you take some piece of compiled code, we can tell you without seeing the source code exactly how it behaves and what it does. Lots of things like that. And I think you'd be hard pressed to go to somewhere even like Google and find that they're doing the breadth of the stuff that we do.
What is at the intersection of security and deep learning?
So again, like I mentioned, with a lot of security boils down to, at least on the network side, just doing anomaly detection. If you're looking for a user that's out of the normal in your network,
gosh, everything boils down to anomaly detection.
Yeah, absolutely. And that's what I'm trying to say is a lot of that kind of stuff has been just most of it in the past has just been, hey, we're going to apply these basic statistical measures and see how something pops out of the normal. But we haven't been applying things like recurrent neural networks or convolutional neural networks or more advanced types of deep learning to anomaly detection and security and the security domain in general.
How do the motivations of Oak Ridge compare to those of NSA or FBI or other governmentally related organizations?
Yeah, I don't really have that, so I don't want to say too much.
That's fine. That's fine.
I just don't know exactly. I don't know how exactly to answer that. But I can say that places like the NSA and FBI, their goal is to protect our country, protect our assets, protect those kinds of things. Where at Oak Ridge, we have directorates for environmental science, for supercomputing. I mean, we have the world's second fastest supercomputer that just got beat by China's. And China's isn't even open science, but we're currently building the fastest again, which will be powered by NVIDIA clusters. So we bring in people from all over the world. We have a particle accelerator at our lab that brings people from as far as Japan and China just to come work on our projects. And then we have this tiny little cybersecurity research group inside the lab, and we do, like I said, all the stuff that I've talked to you about.
Have you thought deeply about the conversations around the Russia hacking stuff recently?
My opinion on that, and I try and stay out of it, I think if you just look on Twitter, and I follow a lot of security people, the opinions on what actually happened are far and varied.
They are.
And I'm not in a position to tell you whether it's true or not, but I will tell you the attribution is very hard. We will never know exactly what information, the agencies that were investigating it had. But it's something you either just believe them or you don't, and you go your merry way about it. And what happened. So it is not an easy thing to attribute something like that to a country.
And this is something that I think is actually really important because there's so much acrimony around this, and like whether you're a fan of Trump or not, like one thing he says that's pretty much true is it is really hard to, Trump says it in his Trumpian language, but he's like, we can't, in the computer age, we don't know what's going on. And it's like, that's kind of true. Like attribution is really, really hard. And the kind I really don't want to get political, but it's like the way that things have been gesticulated by the government and interpreted by the media is that we are really sure of this. And the reality is, given the public information, we have not been given convincing evidence. That's just simply the reality.
I mean, yeah, if you look at the information that's provided, it is very generic in some of the diagrams drawn. But
the Grizzly Step report?
Yeah.
I was like, are you kidding me? Like, how patronizing are you going to be?
And I think if we step back a bit and just look at the interaction between technology and media, we live in a very interesting time where the media more or less claims that everything in technology is advancing, and we've got AI and literally everything, and companies are getting billions of dollars in VC funding for just claiming they do automated AI recognition of speech, or just whatever set of buzzwords they want to string together. But if you go and talk to practitioners in this space, software engineers that you interview in your show, and researchers, I mean, they'll tell you that what the media says is more or less like sometimes it can be very exaggerated. And whether this case is something is a case of that or not, I think it comes down to, if you're a person, you need to look at all the evidence you have and just make a good judgment on it. But I think it's something we can't really do much about. We're not going to know exactly what happened, and you just kind of have to deal with it.
And something that I've kind of woken up to around this stuff is just like, I don't know, it's the first time I really am feeling like the influence of the media on my own thinking, like how deeply the media affects me. And at the same time, there's so much like the discussion around Russia is like, oh, Russia's this horrible place run by a leader who just pollutes his citizens' minds with propaganda. And I'm thinking about that, and I'm like thinking about the way that our media portrays things, and like, I'm not an expert on U.S.-Russia relations. I'm not an expert on Russia, but I just look at that and I'm like, there's a deep irony there to the reportings of a propaganda-driven nation. When we're having these kinds of discussions. But anyway, I mean, the power and then the power grid hacking discussion that came out, it was like, oh, Russia has hacked our power grid. I was like, didn't they do that like 8 years ago, or like, and haven't we already hacked the power grid of every other nation state out there that is connected to the internet? I mean, there's such like a nationalistic discussion here where it's like, oh, as the United States, we are entitled to not have our power grid hacked while we go and hack the power grids of everywhere else. Like, doesn't this seem strange to you?
Yeah, and it is. I think that's why it's called. So my team at the National Lab is called the Cyber Warfare Research Team. I mean, as much as people want to crap on using the word cyber and everything, I think it is pretty true. We live in an age where nuclear power is not the most triumphant force in our arsenal, and cyber and security in general is something that is going to become ever more important. And that's why I think getting back to just protecting your web applications from hackers and hashing your passwords, just doing that and using two-factor auth is extremely important. It's not often that some attack on a nation state or some company is a result of a very complex chain of 0 days that the hackers use. It's almost always just someone that compromises an email account, and it happens that person has privileges to everything in the network, and then they can steal whatever they want. It's not a very hard problem to solve to do as much as just educating your people on, using two-factor auth. That being said, education is tough, but I think just putting more focus on that and spending more money on that within companies would make a big difference.
You mentioned the string of 0 days, obviously referring to Stuxnet, which was a vulnerability that it was the result of loopholing through a bunch of 0-day attacks. And, you and I were talking offline about this because I had a conversation with Sammy Kamkar recently where I discussed this a little bit. Do you have any more insights into how, because the thing that I was wondering about, that I asked Sammy about, is like, did Stuxnet actually change? Because the narrative around Stuxnet is like Stuxnet and Flame changed how the geopolitical stakes for cyber warfare, because it laid a blueprint for how things could be infiltrated and how tracks can be covered, like how you can mess with the system and then basically erase any evidence of the change. Like, no evidence. There will be no evidence of the attack. Do you think Stuxnet raised the stakes, or what are the implications of Stuxnet?
Yeah, I think one, it did raise the stakes in the sense that it made people aware that those kinds of things exist. And if you look in the past few years, we've had things like was it the hacking team from Italy? I think that's an Italian group, or Lizard Squad, the people that DOSed, they were the ones that DOSed Sony, right? And you look at these huge incidents that are getting mass coverage in the media, and especially something like Stuxnet, where it was a application of unrivaled complexity that was able to take down what was a nuclear plant in Iran, I believe. And I think Sammy mentioned in his show how modular that was becoming because it was built on Flame, and that is what really scares me, is that when we start developing these components, and attackers start developing these components, where it's really easy just to string together the pieces they need in the 0 days that they have into something they can do as much as bring down a nuclear plant or take down a power grid, we're looking at really scary times, because the rest of us are just building React apps for our front ends, or doing this cool data science stuff for Python, and in the meantime there's some nation state or some isolated group in the Ukraine that's ready just to destroy our country's power infrastructure, and it is not. And I do some stuff with the power grid at school where I'm a PhD student, and it is a pretty fickle system. It is not that advanced. We're really working on renewing a lot of the technology there, but if you think ours is bad, just look at some of these other countries, and if you think if our power grid went down for the whole country's power grid, if it went down for 3 days, we would be in a state of anarchy. People would be flipping out. The whole country would be a mess, and it is a very scary time. And I think Stuxnet was one of the first things to really bring a lot of public light to that.
And what I have heard, I think this was in a discussion I had with Alec Ross, who came on the show to discuss his book, Industries of the Future. He worked in government for a while, and he was saying that in the power grid conversation, Russia has a bit of a positional advantage because of how old and offline their power systems are, if I recall the conversation correctly. So they're essentially air-gapped. Is there any truth to that?
I'm not that familiar at all with how Russia's is built, and I am a little familiar with how ours is, in the sense that we have, I think, 3 or 4 sectors of our country's grid, and they're all connected in between those, and it is old technology, but I think. Yeah, I don't know. I'm not too familiar with
what's the technology stack of the United States power grid?
I mean, a lot of it is still analog, and even the stuff that's digital, we're not running, Ubuntu 16.04 boxes to control switches and stuff. At least my understanding. And again, you're looking at a very fragmented system because there are a lot of parties at play. It's not again, to use like the canonical like Google or Facebook example. At least within those companies, they've got project managers that manage the different projects and engineers that all build around the same technology. But when we build something like a grid that spans, hundreds of thousands of like nodes within the United States, we're looking at all these different parties coming into play and influencing how stuff is built and what they're going to put in and those kinds of things. So that, again, we talked about attack surfaces earlier. That just makes the attack surface very, very, very wide, and that just leaves more places for people to get in. But I hope, at least how it stands now, that it have to be a fairly complicated and hands-on attack to actually mess around with it. That may be false, but again, we haven't seen anything of the scale of Stuxnet on our power grids or anything like that.
When you say that the systems are analog, does that end up being a feature because it's less hackable?
I mean, yeah, in some sense, we don't have, rootkits for that kind of stuff. I don't think so. But it does. The older technology does help a lot, and I think if you look just at like our nuclear launch stuff and all of the things around our nuclear arsenal, I don't know a lot about that either, but what I do know is that we're not, again, running very complicated network software to control those kinds of things. I mean, I saw a tweet the other day on Twitter that somebody was talking about it, and someone was saying, hey, we need better technology for our nuclear arsenals, and the other person was like, hey, I'd be very comfortable if it took a floppy disk just to start kind of launching some kind of nuclear device, because, hey, we don't need some kid in some village somewhere sending a TCP packet that sets off all of our silos to launch missiles at Russia.
That sounds great to me. I mean, this is because I think I read this thing by Bruce Schneier. I think Bruce Schneier was talking about voting systems, and he was like, voting systems should just be like old style paper ballots because they're too important. And that is actually, I think that's this kind of similar. Well, at least the system that we have is like multivariate, and it has, and there's different different types of voting systems throughout the country. So even if one voting system was hacked, you would have to hack all the different types of voting systems. So you do have this heterogeneity. I don't know. Well, okay. So what else have you? I mean, that's very interesting that you do research on the power grid. That's like as important as it gets. What kind of stuff are you discovering, or what are you thinking about?
With the power grid in particular?
Yes, I mean, like, what areas are you looking at? What aspects of your research, or tell me more about your research?
Again, I didn't mean to. I'm not proclaiming myself as an expert on that. I am a little familiar with the research that they do at my university on that, but I don't do hands-on research myself. I just interface with them.
I see.
But again, I can connect you to the people that do that. At least here, how I've seen, security isn't as nearly as big of a focus in the power grid as just modernizing the grid itself. And I think that is something that we do a lot. Where we're doing some efforts to simulate the whole grid, and by simulating it, can we see if we can improve technologies within it and see how we can improve power flow. And another big problem within the grid itself is just how can we supply power to the amount of people that are bringing online every day. That's a big issue as well.
Okay, well, let's talk about what you said was the hot topic right now, IoT. So the obvious elephant in the room is the Mirai botnet, which is this botnet that took down Dyn DNS, and downstream from that took down Netflix and Twitter. And the attack manifested because there was a large volume of cameras in IoT cameras, well, all kinds of IoT devices. I think mostly cameras, but the cameras all had default login and username and password credentials. And so the Mirai botnet essentially scans the internet for these devices. It finds ones that have the same default username and password as any device that comes out of this one Chinese company that makes these cameras, and creates a giant botnet. What's next in the Mirai story? Because we know that this attack could have been a lot worse.
They decided to take out Dyn, which in the case of Dyn was the service that a lot of places like Twitter and GitHub and those other places used. I mean, just imagine if they decided to go after some piece of our military's DNS functionality or some piece of our government's functionality. Again, those networks are a lot more hardened than the stuff that we see in the private sector. They've got a lot more infrastructure there. But if that's when we start talking about cyber warfare, if they were to target some government entity within the U.S. and bring down maybe our communication systems, that's very, very bad if they were able to stop us from communicating in the case of some attack. And I think with IoT, it is just a crap show how much stuff is going on there. If you looked at CES this past week, I think LG released a refrigerator that's now going to talk to you. And I'm just thinking, like, holy crap, why are we putting IP addresses on literally everything we have? That is such a bad idea. And again, with the Mirai botnet, it wasn't only cameras. I also heard it was cable boxes. And I'm thinking, why do we need to have these cable boxes on the public internet and hundreds of thousands of people's houses that have default credentials? Because of course people don't change their credentials. Like, why would you do that? Why would you do that? I mean, people just don't think about it. They should, but they don't. And like Sammy Kamkar mentioned, if companies were just to disable default credentials and the first time you logged in or set up, you had to set credentials up, that would solve, a lot of those problems. And it would at least present another barrier to the attackers that did the Mirai stuff.
Yeah. I mean, so I also asked Sammy about this quote from Bruce Schneier, where Bruce was saying that the free market can't fix this. Do you have any thoughts on that idea? Like, are the free market pressures enough to force the IoT industry to do something about this, or not?
Yeah, I think with that and what he's mentioning there, it does bring up a very interesting point. I think it's really hard to convince companies to build more security in their platforms just on the basis of, hey, this is a good thing to do. I think that's where we step into how much regulation do we need by the government entities or just general like agreements or treaties even between companies saying, hey, we're not going to produce stuff without these core security features. And we already see this kind of work being done with protocols being developed by the IETF and other internet standards organizations. I think the next steps are to get companies to think more about this.
Speaking of companies, governments at this point have these backdoors into Facebook and Google and Twitter, and these backdoors are to varying degrees. Given that you work for the government or, work for an institution that's closely connected to the government, I would love to hear your thoughts on, I guess, privacy basically is a discussion, or privacy from the government. We also had this conversation with Sammy, but yeah, I'd love to hear what your thoughts are.
So Sammy had an interesting point and I was surprised that he said this, where he more or less said his view has kind of changed, or at least he knows what he wants, but he doesn't know what's best for everybody. And I think to the extent that the government needs to protect our country and our assets from terrorists and insider threats and spies and those kind of things, I think there is a amount of reasonableness to why they want to have this information. But again, it can be taken too far. And I think too much information or too much openness or, backdoors that can take a lot of information that might not be necessary is an infringement of privacy. But again, as a software engineer and even as a security researcher, I think privacy is a huge deal. And again, it comes down to user trust. If your users can't trust you, if they just think by going on your site that all that information is going to get dumped to some entity that's going to comb through it, then they're not going to want to use your platform. And that's, I think, the big reason why a lot of companies want that is because, again, they're going to trust you. But also, Sammy mentioned the vulnerability project he found with Google tracking your phone's MAC addresses. And I think even though we've got these backdoors, or if they do exist, then they're there in these companies. Companies like Google and Facebook, they still want to know literally every single thing about you and use it to sell more advertising dollars and all kinds of things like that. So it does go both ways. And again, even if there's not backdoors, that company is still going to want to have all your personal information.
Do you feel personally vulnerable or violated when that kind of information sharing is taking place?
It depends. I've been fortunate enough not to have any sort of major breach of my privacy online. I think that comes down to having good, practices.
Well, no, I'm referring to like Facebook or Google giving the government everything for backdoors.
I may have a weird opinion on it. I'm more or less okay with it if it's for the right purposes. For my case, I'm not going to say that for everybody. But my opinion is, hey, if we're going to give all this information to Facebook and Google, what's stopping them from giving it to anybody else? We have no idea. The amount of transparency that exists there is next to none. So if the government gets it and they use it for some kind of purpose that is going to help us or to hurt us, at the end of the day, they still have all that information and they're going to get it if they want to get it.
Well, and there's such... people don't talk about this as much, but there would be such massive opportunity if the data sharing was more viewed as being more kosher on the part of citizens. Like if the government could do massive analytics that Facebook or Google has no interest in doing, like I would feel a lot better about spending my tax dollar, my tax dollars being siphoned off if I thought the government was doing like all kinds of analytics on the exhaust data that Facebook and Google were giving them to decide, I don't know, like what do we do with healthcare? Like what should we do with potentially basic income? Like these are like really, really big questions. And basically the way that they are often solved in government is through superstition and like just stupid biased beliefs. And I think it would be awesome if they could actually have data to do that with.
Well, just think if you went to the average, mom that has Facebook and you told them, hey, I want it to be that when you record your birthdays and tell people, hey, thanks for like coming over to my house for that, that get together, and hey, my kid's doing this activity. If you want to tell them, hey, we're going to give all that information to the government or, Facebook, so they can give it to people to decide what your tax bracket should be or your how your roads should be built, they're going to freak out because they're going to be like, oh, I don't want them meddling in that. I'll just deal with it myself and I'll just keep dealing with the same problems I have. So I think it's helpful to step back and be like, if for someone that's not familiar with technology like we are, those kinds of issues really scare them. And if you just talk to your parents about that, I'm sure they're going to have a hugely different perspective than you and I would. And I think that tying it back to the big picture, the gap between regular society and the people that are technology practitioners is growing every single day. And it's actually very, very scary how much discord there is between those two parties.
That is absolutely right. And oh man, how does that manifest in your everyday life?
I recently graduated from college. I talk to my parents a lot. I have a brother that's, not a software engineer, does completely different things. And if you just talk to your family, the kinds of like perspectives and things are very, very different. And so in my life, it manifests through that. But I'm lucky to, I was a computer science major, so I have a lot of computer science friends. Most people in college are somewhat more technologically inclined. But I think, again, that probably has to do with, too, being, somewhat of a millennial, being born in 1995. My life has been very different from that of, my parents or someone born in, the 70s or 80s. And it is a very tough question that how do we reconcile the amount of discord between the older generation and our generation, because we have people in Silicon Valley just building technology and it's just being pushed on people everywhere else, and those people just kind of have to accept it. Facebook makes a new feature that collects your camera data and they can't do anything about it, but they're going to use Facebook because all their friends are on there. So how do you deal with this?
The technologist versus non-technologist schism feels like perhaps the biggest schism that I've encountered in my life. Like definitely bigger than like religious versus non-religious. It permeates everyday life. And like you just have conversations with people about job displacement, for example, and the conversations that technologists have around that discussion versus non-technologists are just so dramatically different. And there's a lot of gulfs develop because of that. So given that you work in this government or semi-government institution, do you consider yourself more as somebody who's trying to do security work that benefits the United States, or do you think of yourself more as a global citizen?
I think kind of it goes both ways. I think a lot of the stuff we do ends up being used by the government, and a lot of the stuff we do ends up being licensed by some startup or some other company to be used. And at least in my group, we do the security, so a lot of our stuff is stuff with government agencies. But if you look at some of the other directorates within our organization, they're doing stuff, with the supercomputer or environmental science, and those kinds of people are contributing more to the global state. But I don't like to think of myself as, hey, I work at a government lab, I'm just a government cog in the wheel. I like to go and be like, okay, what am I going to do today in security that's going to benefit everyone around me? Because, whatever kind of technology we can provide to the government or to the private sector is hopefully going to help, because we've got some of the smartest people I know there. I mean, almost everyone has a PhD from some crazy school, and they're all just doing this awesome stuff. So we're not just thinking, hey, how can we build stuff just to collect more data about people? We're like, how can we protect everyone, not just the government, from being hacked by other countries, or being able to uncover security problems more easily and things like that.
Continuous integration gives you faster, safer software delivery. With a continuous integration tool like Snap CI from ThoughtWorks, the members of your team can push changes independently of each other, and they can all see their new builds running against different phases of tests before those changes make their way into production. The fastest moving companies that I've talked to on Software Engineering Daily are all using continuous integration. Snap CI from ThoughtWorks is available to anyone. And if you go to snap.ci/software engineering daily, you can check it out for yourself and support Software Engineering Daily. With just a few clicks, I had my own continuous integration set up for some projects that were just sitting in my GitHub account without continuous integration. I got continuous integration up quite easily using Snap CI. If you want to be that hero at your company that starts moving your organization towards deploying often, more confidently, towards that DevOps dream, start working with Snap CI at snap.ci/software engineering daily. Your coworkers will see you working with Snap CI, and they will fall in love with it themselves. Oftentimes, it takes somebody at a bigger company to go out on their own and say, okay, I'm going to roll out CI even though nobody else at the company is using it. And maybe that hero at the company is going to be you. So check out snap.ci/software engineering daily. And thanks to ThoughtWorks for being a continued sponsor of Software Engineering Daily. It really means a lot. Talking more about security research, one of the helpful ways of thinking about security for me has been these little principles and adages, like the principle of least privilege, for example. That's something that's true at every layer of the security stack. And I guess another thing that's been helpful for me is seeing vulnerabilities as they appear and then understanding why that vulnerability exists. Like, look at Heartbleed, for example, and if you study like what happened with Heartbleed, the different things that have to occur in order for Heartbleed to be exploited, that is a lesson in and of itself about how security works. As someone who has studied security deeply and you're involved in this stuff on a regular basis, what are the things that have developed your way of thinking around security? What are the strategies you have for thinking about security?
Yeah, so I think one of the biggest things that I like to advocate, and I think that people that do this on a daily basis like to talk about, is just I'd like to get in the head of the people that are going to come after my system. So if you can think like an attacker does, and you can think about how they're going to look at your system. So a good example is if you've got just a login field, they're going to be thinking about, hey, how is this form implemented behind the scenes? You're going to take the username and the password, and maybe you're going to hash the password and check it against some other database. But then if you realize, hey, maybe what they're doing with this password is they're not sanitizing it before it goes to the database. So there you go, right there, you deal with a classic SQL injection. So I think one, thinking about how their mindset has helped me a lot. And two, being a software engineer has helped so much. I can't describe how much knowing how systems are built and building systems on a regular basis helps with things like pen testing and finding flaws in systems. And a lot of the work I do at the lab is more security R&D and more in the research and development side. So we do less of the pen testing, which I used to do a lot more of that at Cisco Systems, but now we actually build things. So in my free time, sometimes I'll do bug bounties, and it helps a lot just to be a software engineer. So I think it's great for the people that listen to your show. Most of these people are software engineers. So I really do recommend they should go check out some bug bounties and just see if they can find stuff, because it helps a lot more if you're coming from the building side than if you're coming from an IT or sysadmin side, because you can think about how systems are built when you look at a website or when you look at some IoT interface or a router page or something like that.
Well, and the psychology discussion is interesting. That's all, what you mentioned about like how to build a more secure system, put yourself in the head of the attacker. Sammy Kamkar is somebody who looks for exploits, and he said, put yourself in the head of the builder. So what you're implying there is it's just this like two-sided psychology thing, which I guess makes sense. It's just interesting to hear that come full circle.
Yeah, and I think when I'm saying put yourself in the head of an attacker, I'm talking about from the side of defending your systems. And when Sammy said putting yourself in the head of a builder, that's how I was talking about how it's helped me to penetrate systems being a software engineer. So there are these two sides. If you're someone trying to get in, think about how they would have built it. How would you build something like that? How would you mess up some kind of some protection, things like that? Psychology plays a large role in security, and it's a great field to be in because you end up dealing with a lot of disparate types of information and things you get to learn about.
There was a show I did a while ago with Pindrop Security, which is doing basically security for voice, like for call centers. You call in to a bank, and if without a secure voice system, I can masquerade as Bill Gates and say, could you please transfer $1 billion to Jeff Meyerson? He's doing some podcasting for me. And because they can't verify my voice, they just assume I'm Bill Gates. And so, I remember doing that show, and then they were talking about, like, yeah, you could potentially use this for like Amazon Alexa or Google Home. If Google Home needs to authenticate who you are, they would want to have this security layer. And the reason I bring that up is just because we have so many attack surfaces that are nascent these days, like voice, cars, drones. IoT is a very general term, but we've obviously already discussed that. I think the reason we discussed IoT and we haven't really had a mainstream. I guess the conversation about cars and drones is getting more mainstream, but these things are not in rapid deployment. How is the security industry going to keep up with all of these different attack surfaces?
It's a great question. It is not something that's basically like asking, how are we going to protect every single device on the internet as they become more and more varied? And I think at the end of the day, again, focusing on basics is an important thing. I think thinking about security education, how do we educate developers? Because a lot of times the people that are building these applications are developers that have, a minor amount of experience with security. You're not going to get security engineers and pen testers and researchers as the ones building the products for you and me. But I think we benefit a lot from the companies putting out a lot of these major devices like Alexa and Google Home as being more battle-hardened, security companies in their core practices. I think you'd be hard pressed to go interview with Google and not get a question about, how do you prevent some kind of a sanitization flaw or something like that. But again, with that, I don't think I can tell you the right answer to that. I don't think there is one. But I think it's something just if people that are developing technology just realize security is a problem, that will go a lot farther than them just completely ignoring it. And I was really happy to come talk to you on this show, because I hope people get out of this that security is not something you just throw under the rug and hope nothing happens. Because if you're the one that puts some flaw in your system, whether you get punished or not, your company, which I hope you don't, you're going to live with for the rest of your life that you expose the sensitive data of potentially millions of people. So it is something just needs to be thought about more. And I'm really glad you brought Sammy and some of these other people on the show to talk about it.
Yeah, and if the past is any indication of the future, with these new systems, there's just going to be these speed bumps over time where we're going to have car-related deaths, we're going to have drone-related deaths, we're going to have voice-related theft and spoofing, and it's going to be a crazy time. And the developers who leave their systems vulnerable are, like you said, going to have to live with perhaps somebody dying because of an issue with their system. And yeah, scary times.
Remembering back to the vulnerability that Chris Valasek, I think you interviewed him on the show, with the Jeep hack. That just blew my mind. If you have a car going 60 miles, 70 miles an hour down the highway, and you're sitting at your house and you can connect to that car from the public internet, and you can just shift it into reverse when they're going 70 miles an hour, you're going to kill at least multiple people, if not more, that get injured in the wreck. That is something that developers cannot afford to not think about.
Yeah, and I feel like we're at a certain point where there hasn't been much intersection between like terrorists and hackers, at least as far as I know. But as you have vulnerabilities in cars like that, I'm sure and the ability to learn technology is getting more and more widespread. You could have a 13-year-old hacker who has been indoctrinated with radicalism, and that hacker would be motivated to do stuff like that and would have the ability to do stuff like that. It's just going to be a tremendously scary time. Okay, so what are some of the aspects of security that we have not discussed? What are the things that people are not considering deeply? What are the messages you would like to get out about security?
I think one of the big things I like to think about in a lot of my research is at UT, where I'm doing my PhD, is network security. I think if you think about how our internet actually works at a fundamental level, with networking protocols like BGP, which is Border Gateway Protocol, and TCP and DNS and those kind of things, vulnerabilities in those protocols have a large impact on pretty much the entire internet infrastructure. Just look back at the Heartbleed bug in SSL. That was there in the system for like a year and a half to 2 years before it was publicly disclosed. And think about all the people that discovered that before then that didn't actually reveal that existed. How many companies, governments, nation state actors were using that information to exploit people's servers. So I think thinking about protocols themselves and what their vulnerabilities are is important, because at the end of the day, web applications are not the only medium of how information gets on the internet. All of those things are powered by the underlying layers of the TCP IP stack.
I have a broader question. If we go to war with some other major nation state, like whether it's Russia or China or North Korea, do you think it's going to be a purely cyber war, like a cyber war, robot war? Or do you think, are we still in an age where a draft can occur and there will be actual war? I know this is more of like a diplomatic security question, but have you thought about this at all?
Yeah, I have a little bit, and I think cyber and security warfare in general is going to be a component of the other pieces of the puzzle. I think it'd be pretty out of the question for a massive war to break out without there being a physical component to it. At least right now, as much as we in the technology community make a big deal about having robots and all these chatbots and AI that does crazy, ridiculous things, we do not have bots on the ground that are able to handle weapons well enough not to kill innocent people or commit friendly fire. So I think there'll be a physical component to it, at least right now. But I think cyber warfare plays that the ancillary role or peripheral role to it. I think that would be more of a first strike on the country before we try and barge in than it would be something that would be just solely that going on. And I think it's a very undefined territory. And if you just look at the government and look into some of the proposals and stuff going on, there's a lot of funding, a lot of research going on in more of the typical military settings on cyber warfare, just because they realize it's going to be something that's going to be important for us to utilize in the case of some global catastrophe like that. So it's just going to get more important. And that's why I think security is a great field, because at least in my lifetime, I don't think I'm ever going to be out of a job. I may be out of a job if I want to do, it's just some kind of typical app development, but security is always going to be important. And as much AI as we put into it, there's always going to be other problems people find with it that are going to cause us to have real people thinking about how to protect those systems.
Okay, final question. Do you have any personal security precautions for everyday life that you take, other than, I guess, the obvious two-factor authentication? Any interesting tools that you use?
If you really don't want people to track you on the web, use something like Tor. Just look up Tor Project. That's a very great browser that essentially, it's a complicated discussion on how it actually works, and you should get some people on the show to talk about that. But it basically masks your IP wherever you go. So using Tor or VPN is a first step. But again, just as simple as using a search engine like DuckDuckGo, which doesn't track any of your information, over Google if you're really scared about it. Again, we mentioned two-factor auth. And something else that's actually really important is just encrypt your hard drives. If you have a Mac, then use File Vault. If you have a Windows computer, or get BitLocker, which is built in some of the more premium versions of Windows. Just doing things like that are important. And again, not only using two-factor auth, but using strong passwords. I have a lot of family and friends that are in tech that will just use their name and their birthday for that. I can find that in your Facebook if I go to your profile. And I'll have a dictionary that my automated Python script will run against your websites and get in with that password. So if you really don't want your Facebook to be hacked and people to post about Ray-Bans that they're trying to sell to you on Facebook, then you should probably use strong passwords. But again, you can find, a dozen posts on the things to use, but I think those are some of the biggest things I'd recommend.
Okay. Well, Jared, thank you for coming on the show, and thanks for being a listener to Software Engineering Daily. I really appreciate the feedback that you've given to me over the past several months. And your talk, I watched your talk on web security from Nodevember. I'll put that in the show notes. It's a great discussion. We didn't really get into much about specific JavaScript security and web security stuff, but there's a ton in that talk, which I really endorse. So if you're interested, go check it out.
Yeah, absolutely. And thank you for having me. And if you want to see more ramblings about this, just follow me on Twitter at Jared the Coder, because, there's a billion Jared Smiths in the world, so I had to specialize there. But thanks, Jeff. This show has been great. I've been listening since like the 10th episode, I think. So you're doing a great thing for the community.
Fantastic. All right. Well, thanks, Jared. Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks again, Symphono.
Wow.